Welcome to qnawire.
Okay, so for this question, we know the pressure is given as a 0.25 megapascal and the temperature is 50 degrees Celsius, which is 323 Kelvin, and the velocity is 240 meter per second. So therefore, I have the T0 is equal to T plus V squared over 2Cp. T0 is the stagnation temperature we're looking for to determine. So if you take a look at the table of the ideal gas specific heat of various common gases, so the specific heat for the helium is 5.1926 kilojoule per kilogram times Kelvin. So therefore, can plug in back to the equation to determine the stagnation temperature in this case, which is equal to 323 Kelvin plus 240 meter per second to the power 2. And remember, we need to convert to kilojoule per kilograms because our final units is Kelvin. And only kilojoule per kilogram divided by kilojoule per kilogram times Kelvin will give us Kelvin. Okay? So we know 1 kilojoule per kilogram is about 1,000 meters squared per second square. Okay? And then divide by 2 times 5.1926 kilojoule per kilogram times Kelvin. And this will give us the stagnation temperature is about 329 Kelvin. So now let's try to determine the stagnation pressure, which is P0 equal to P times T0 over T times K over K minus 1. So we know K, which is the specific heat ratio for the helium, is about 1.67, and the T0, which is the stagnation temperature, we just figure out, which is 329 Kelvin. So now let's plug in back to the equation to determine the stagnation pressure, which is equal to, let me see what's the pressure, 0.25 megapascal multiplied by 329 Kelvin divided by 323 Kelvin, and to the power of 1.667 over 1.667 minus 1. And this will give us the stagnation pressure for the helium in this case is about 0.262 megapascal, which is 262 kilopascal. So now let's take a look at the second case. So for the nitrogen, we know the pressure is 0.15 megapascal. The temperature is the same, which is 323 Kelvin, and the velocity is 300 meter per second. If we take a look at the table for the ideal gas specific heats of various common gases, which is table A2, you'll find that the specific heat for the nitrogen is about 1.039 kilojoule per kilogram times Kelvin, and its specific heat ratio is 1.400. So now let's plug in back to the equation to determine the stagnation temperature, which is equal to 0.15 megapascal plus, I'm sorry, not megapascal. Oh, making a mistake here. It's a temperature, my bad. So it's 323 Kelvin plus 300 meter per second to the power 2, and then times 1 kilojoule per kilogram over 1,000 meters squared per second square. And then over 2 Cp, which is 2 times 1.039 kilojoule per kilogram times Kelvin. And this will give us the stagnation temperature is about 366 Kelvin. So now let's determine the stagnation pressure, which can be equal to 0.15 megapascal multiplied by T0, which is 366 Kelvin over 323 Kelvin to the power of 1.4 and then over 1.4 minus 1. And this will give us the stagnation pressure for nitrogen is about 0.232 megapascal, which is 232 kilopascal. For the next question, so for the steam, we know the pressure is given as 0.1 megapascal, and the temperature is 350 degrees Celsius, which is 623 Kelvin. And the velocity is given as 480 meter per second. If you take a look at the table A2, you'll find that the specific heat for the steam is about 1.8723 kilojoule per kilogram times Kelvin, and the specific heat ratio is 1.327. So now let's plug in back to the equation to determine these stagnation temperature first, which is equal to 623 Kelvin plus 480 meter per second square, then times 1 kilojoule per kilogram over 1,000 meter square per second square, and then divided by 2 Cp, which is 2 times 1.8723 kilojoule per kilogram times Kelvin. And this will give us the temperature is about 685 Kelvin. So now let's determine the stagnation pressure. So now let's plug in the values. So we have the static pressure, which is 0.1 megapascal, multiplied by 685 Kelvin divided by 623 Kelvin to the power of 1.327 over 1.327 minus 1. And this will give us the stagnation pressure is about 0.147 megapascal, which is 147 kilopascal. And these are the answers for this question.